Thank you. It really is an honour to be here today and to join a community of such amazing scientists, technologists and engineers. So many of you have inspired me over the years. It's a particular honour to be here on the same day as my new fellow and Vice-Chancellor, Professor Linda Christensen, and I'd like to thank Michael Edwards, not just for nominating me, but for your advice and encouragement over many, many years of my career. So my background is on carbon fibre composites, and these are lightweight, high-strength materials that are used to revolutionise fuel efficiency in the aerospace and automotive industries. They're a combination of a lightweight fibre, bundles of which are held together by an epoxy resin, so you get the benefits of the strength and stiffness of the fibre and the toughness of the epoxy resin. And my career, but more broadly my whole life, has been defined by manufacturing and carbon. And I actually have manufacturing in my DNA. My parents met while they were working for Monsanto. They were both research chemists. So it was kind of inescapable. And I grew up in this family where we were constantly making things. And even as I speak now, my brother is building in his garage a 3D printed, fully autonomous replica of R2-D2. So it just continues to this day. And so I've always been really passionate about making things and working with industry. And my other passion is carbon. I think carbon is just such a fascinating material. To be able to change the bonding and the arrangement of atoms and to radically transform properties so that you can go from, graphite, which is a solid lubricant, to graphene, which has incredible electrical conductivity properties, to carbon fibres. And of course, my favourite allotrope of carbon is diamond, just for future reference. So I was recruited by fellow ATSE fellow Peter Hodgson to start carbon fibre composite research at Deakin in 2001, and I did this by growing the research capabilities there by working closely with industry, and started by working with a company called Quickstep, who are a 3-person startup with a prototype a piece of technology that was built from hot water services. And so it was really amazing to be part of their growth. They're now supplying parts for the Joint Strike Fighter. They have 2 sites in Sydney and in Geelong, and they employ almost 200 people. The first cohort of students that we had for the Quickstep projects were incredibly talented, innovative local students who invented a prototype wheel, and that grew into Carbon Revolution, and now they're supplying these wheels globally. They're on the Ford GT, and they have a factory on campus at Deakin. And along the way, we identified a need to do research in the fibre itself, and through a really strong partnership with CSIRO, the Victorian Centre for Advanced Materials Manufacturing and Deakin, we created this facility called Carbon Nexus. So I've got a bit of a history of putting big industrial equipment in university campuses, and I think that is the thing that we're missing in Australia. It's a thing that happens a lot more overseas, and it's a big opportunity for us to do really real-world research. But now I'm really interested in the fourth industrial revolution, and there have been a number of other speakers who've mentioned this today. And the reason I became interested in this is because I did a project with a company called Multimatic, where they came to us with a videotape of what would look like a process to make 1 part per minute. So the first ever composite I made in my PhD took 20 hours to cure, and we're now at a point where we can make 1 part per minute, which is incredible. This was a very challenging project. It involved highly exothermic reactions, but we developed a process matched with a chemistry to do this, and that then made me realise that everything else you do to make that particular part is a rate limiting step. How do you cut out the fabric? How do you get it into the tool? How do you demould? How do you inspect? All in that 1 part per minute cure cycle time. So we actually won an award for this with Daimler, Multimatic and the University of Stuttgart, but the thing I'm most proud of is that this is an actual part on a car, and none of you would ever know, none of you will ever see it in the Mercedes S-Class, but it's there and I know it's there, and that's such a big thrill. So now, beyond industrial automation, we're looking at Swinburne at how we can really utilise these new digital tools that are coming about to transform the way that we make composites. And we're really excited by the intersection of smart materials and smart processes. And we think that there's a huge opportunity for Australia here. And so we're creating at Swinburne Australia's first Industry 4.0 test lab, and it's going to be focused on composite product automation. And so to start with the smart materials aspect, we created a use case with our partners in Germany where we were able to integrate, because composites are an engineered material, you can integrate really incredible sensor technologies and impart functionalities, so you can create smart battery skins for electric vehicles that can detect any leaks of fuel. You can create smart structures for autonomous vehicles that will report when they've experienced some damage. So the sensor technology has become lighter and more efficient, and at the same time there's been some incredible innovations in graphene, and that's where I think Australia has a really unique opportunity. We've been working with a company called Imagine Intelligent Materials, who've created a grade of industrial graphene, and they're actually manufacturing 10 tonnes of graphene per year here in Australia. And with this material, they're making smart geotextiles that are capable of detecting leaks, that are capable of reporting back on any impingements into the environment. And I think this is a huge opportunity for us, this new era of graphene where it's cheap and accessible. So I'm really looking forward to contributing to the Academy. I'm particularly passionate about STEM education. My mother, after being a research chemist, and she's here today, became a maths teacher, and I've seen the impact that one inspirational teacher can have on a generation of students. I'm really excited about connecting globally for the benefit of Australia and using research to do that. So researchers are incredibly well connected, so how can we leverage those connections to create business-to-business connections? One example is we just recently held a graphene showcase at the University of Stuttgart in Germany, and that was incredibly well received by more than 30 industry partners there. And then I'm also really passionate about ensuring technology readiness, measuring technology readiness, and then creating a roadmap for improving technology readiness. So I'm ready to roll my sleeves up and to contribute to the Academy, and I'm delighted to join you today. Thank you.